Very good morning to you, Jaideep.
Morning, evening.
Very good morning. We have some participants who have already joined. Jaideep, would you like to set up your presentation?
Yes, let me just share my screen and just check it out. Okay, you need to allow me to share the screen, please.
Yes, actually, Jaideep, we have made you as a co-host. That's
Okay.
been done.
Okay.
We have
Do you see my screen?
yeah, I see. Artemis Humanities Return to the Moon.
Correct. Okay, that's fine.
The participants are joining in. Thank you so much for this, Jaideep. We have Dr. L.K. Sharma, who has already joined in, and other friends. We expect Mr. Sudhir from ISRO anytime to join in.
Okay.
Most welcome to Dr. L.K. Sharma, who is going to be the other eminent speaker in today's program. Good evening to you, Dr. L.K. Sharma.
Good evening, thank you. And good evening, Dr. Jaideep.
Good evening. Good, yes.
Actually, for you, very early good morning.
It's morning for me. Yes. Yes.
Yeah.
I'm having my cup of coffee, so I'll be awake.
Yeah. Good.
We also have Madam Kulvinder, a very senior faculty member from DAV Institute of Management, Faridabad, among other friends who are joining in. Welcome to you, Kulvinder Madam. We also welcome Madam Manvi. Manvi, most welcome to you.
Thank you so very much.
Most welcome. Manvi is a senior official from IPC. IPC is a Global Electronic Industry Association, and Explore the Space is very pleased to join with IPC in doing this event. We expect more number of participants to join in, as we expect our
good afternoon, sir.
Most good afternoon, ma'am. Most good afternoon. Very good afternoon to you. Thank you for taking time in and joining in this presentation. We expect Mr. Sudhir ji to join.
It's a pleasure, sir.
Thank you, ma'am. Thank you. On a different note, Jaideep, Mr. L.K. Sharma was talking about a very major conference on space technology and advanced materials that's going to happen in Poland. A few words on that, Dr. L.K. Sharma, is it possible to share a few words about that conference that you're mentioning?
No, Venkat, that conference is not on space.
It's on advanced materials.
It is in honor of that Dr. Mrityunjay Singh.
Okay.
In Poland, because he is getting the honorary doctorate there.
Okay. Well,
yeah.
Dr. LK, what is the topic about? What is the conference about?
That will be on advanced materials.
Advanced materials.
Yeah, it will be on 1st, 2nd, and 3rd June 2023.
Okay.
Yeah.
We understand that you will be traveling for that.
Yeah.
Thank you again for joining in. We have a few other friends also joining in. We expect Mr. Sudhir Kumar to join in any moment. Most welcome to Sudhirji.
Namaste. How are you?
Namaste, ji. Namaste, namaste. That's,
Very nice.
that's
Okay.
good
Some
morning
time
to
is
Dr.
there.
Jaideep.
Some time is there to start.
Yeah. We have another couple of minutes. We have
No
Dr. Jaideep has joined in, and Dr. LK Sharma has joined in, along with a lot of other eminent participants and a good number of students and faculty. So we
Sure.
have a couple of minutes, Sudhirji.
Sure. No, I'll just mute it. You just let me know. I'll unmute. Okay.
Sure, please.
Okay.
Jaideep, we are all set. We just have 2 minutes to start. It's going to be a very short introductory remarks by me. And then we request Mr. Sudhirji for his inaugural address. And then it's going to be the keynote address by Dr. Jaideep.
Okay, I'm fine. I'm at home. I'm nothing
Thank
to
you.
do today. It's okay.
Thank you. Thank you. We will start in another couple of minutes. We have participants joining in. We have about 40 participants now. Mr. Sudhirji, Dr. Jaideep, Mr. LK Sharma, we are about to start the event. Very good evening to participants in India and good morning to participants from USA. Explore the Space, a space education venture, is pleased to invite you for this webinar on current trends in global space exploration industry. A special welcome to Mr. N. Sudhir Kumar, Director, CBPO ISRO Headquarters, Bengaluru, who has kindly consented to inaugurate this webinar. It is our honor that we have Mr. Sudhir Kumar amongst us today. ISRO has become the most inspiring scientific organization for the Indian youth today. Thank you, Mr. Sudhirji, for being with us today. Ladies and gentlemen, I am pleased to present Dr. Jaideep Mukherjee, Director, NASA FSDC, Florida, USA, an eminent scientist from NASA, USA, who will be delivering the keynote address on Artemis mission. Artemis mission is a great project of NASA that seeks to put humans in moon and explore further on to the planet Mars. We are also pleased to welcome Dr. LK Sharma, CEO, Mahamana Ceramic Development Organization, New Delhi, who will speak on space exploration. Industry calls for multidisciplinary talent. Ladies and gentlemen, it is a great opportunity to collaborate with IPC, a global electronic industry association headquartered in Chicago, USA, and with member companies across the globe. We welcome our friends, Mr. Gaurav, Executive Director of IPC, and Madam Manvi Kapoor from IPC to this event. IPC is a very important voice of the global electronics industry. Friends, on the current trends in global space exploration industry, reusable rockets, microsatellites, LEO space stations, deep space missions are some of the latest trends and ideas. In fact, according to a report, pharmaceutical companies sometime in the near future might establish a lab on a space station to study cell growth. Or semiconductor companies might manufacture chips in the extraterrestrial factories. Well, the speedy changes happening in the space industry are just mind-boggling. This webinar, inaugurated by senior officials from ISRO and keynote address to be given by a very senior official from NASA, is a very good symbol of Indo-US space cooperation. At this point, it will be very relevant to mention the ongoing NASA-ISRO joint venture, NISAR, an Earth observation satellite being jointly developed by NASA and ISRO. According to a report, NISAR will map the entire globe in 12 days and provide valuable data for understanding changes in Earth's ecosystems. We are very glad to welcome participating delegates from 23 different educational institutions spread across 15 cities and towns in India, and also a few delegates joining from United States of America. As Explore the Space works with the mission Space Education for Youth across geographies and Space Unites the World, we are pleased to inform you about our forthcoming projects. Explore the Space, the international online certificate course on STEM and basics of space technology and industry, will be available in the public domain shortly. We are also pleased to launch a new project to identify and celebrate youth talent in STEM and space technology in USA and India. That will be an Indo-US collaboration in space education, research, and industry. We will have these programs in different university campuses in India and USA, starting from UC Davis, USA in California. With these words, I take pleasure in inviting Shri Sudhirji, Director, CBPO ISRO, Bengaluru, to give the inaugural address. Over to you, Shri Sudhir sir.
Hi, Giri. Hi, Sir Jaydeep. How are you?
I'm doing fine. How are you? Glad to
Very
see you
fine, very
again
fine.
virtually.
Yes, yes. The friendship should perish and should continue like this. At least Venkatagiri is making that to happen. Very nice getting connected. Hello, Dr. Sharma ji. It's very nice to get connected. I think our Venkatagiri is doing an amazing job connecting the people, connecting the students, enthusiasts across the globe to understand what is happening in the real-time situation, not only in the space domain, but also in the industry, academia, etc. Venkatagiri, can you just ask them, other people, to just mute it so that
Yeah, sure. Definitely.
So I'm very happy to note such kind of events are happening, at least for enlightening the people and understanding the need of the hours, especially post reforms when Indian Space Organization and domain got open to the non-governmental sectors. Many opportunities are coming out because what we were not thinking in the past, we think that always launch vehicles are proprietary to the government. Satellites are national security issues will be there. Satellites nobody would fly. Very keen technologies like, let us say, energy development, solar cells development, composites development, or heat, the thermal systems development, thrusters development, such kind of things slowly going to the private sector. The startups which was not heard maybe a couple of years in India, now they are becoming the actual role models for even corporates to set some standards in an innovative platforms or in a creative platforms. If you see by and large how the space is going up and up, The constellations, what recently even India has launched the OneWeb, say 2 sets of satellites, 36 each, which has paved a way for low Earth orbits constellations in the communication SATCOM areas. That is becoming now growing day by day. Many more, let us say, corporates are coming in this framework. And geospatial platform, it is becoming the order of the day for assessing the agriculture, for assessing the potential hazards because of the natural calamities, for let us say commercial things, for insurance purpose, for banking purpose, for digital, let us say transformation purpose. Satellite technology is now becoming the vital element or technology enabler for implementing such kind of beautiful social solutions. Now I think the as it is growing, it is going in an exponential way. The capacity building is happening across the country. What we call urbanization is happening, which is creating a lot of demand on the broadband sector across the country. The technology is flowing from one country to others. So it all puts a lot of let us say demand on the space technologies and space applications and space resources. I think industry is gearing up. The technology, the conference at this juncture, connecting suitable people and understanding what is happening elsewhere and understanding the benchmarks and understanding the best practice is the order of the day. I hope this conference would result in a good insight to the people who are enthused to listen to this one. I'm very happy, Jaideep. I was interested to, I was asking about Artemis, even though he talked about, I will also be a silent listener to him. What is the new development is happening at Artemis? And a couple of questions have come out whether ISRO is joining in Artemis or not. Yes, that is the decision is yet to be taken by Government of India. And NISAR program, what Giri has mentioned, is a very interesting project which scheduled to launch in the next early part of the next year. In fact, JPL team was here a couple of months back. I was also involved in a very closed loop in the media management and connecting the people. That is also going on very constructive way. I hope such kind of seminars will result in enlightenment of the people, getting to understand what is happening elsewhere within the country and outside the country, what all the opportunities and avenues are available in the space sector, even whether it is a student or whether it is a space enthusiast or whether it is a startup or whether it is a multinational company. What is happening, what is supposed to happen, what all the opportunities get to know is very important aspect. I hope this conference or seminar will result in such kind of let us say important milestones. Please enjoy, the students and other people, please enjoy, get to know, listen to the people and take a note of it and see that this journey will continue. Thank you.
Thank you very much, Sudhirji. Thank you very much. We also take pleasure in welcoming Dr. Ebenezer and students from the physics department of Pope John Paul College in Pondicherry. Most welcome, sir. Ladies and gentlemen, on behalf of all of you, we convey a special thanks to Mr. Sudhirji. You have taken your time off on a very busy day and being with us. Thank you so very much. Friends, now it's my pleasure to invite Dr. Jaideep Mukherjee, Director of NASA Florida Space Grant Consortium. It is an association of 17 public and private Florida universities and colleges, which is led by the University of Central Florida and administered by the Florida Space Institute. It will be very interesting to note that Dr. Jaideep Mukherjee received his bachelor's degree in physics from St. Xavier's College, Mumbai, and master's degree in physics from Mumbai University, and then went on to do his MS and PhD degree in astronomy from the University of Florida. Over to you, Dr. Jaideep.
Well, thank you. Sudhir, thank you for always taking part in these in these programs. You are the face of ISRO to so many students over here, and it makes a big difference. So thank you again. Venkatraman, thank you for inviting me to talk to the students. You have asked me to talk about the Artemis mission, but you also requested me to talk briefly about the global trends in the space industry. So I'll do that. I'll start by talking about the global trends in space industry, and then talk about the Artemis mission. And finally, I'll talk a bit about careers in space for school and college students. So I'm going to share my screen and we're going to start with the presentation. 1 second. Okay. Can you see my screen? Can you see my screen? Venkatagiri? Can anyone say yes? You can.
Yes.
Okay, got it.
Yes, we can see.
Thank you. So I will talk about the Artemis mission, but let me quickly give an idea on what I want to talk about. I want to talk about the global trends in space industry very briefly, but then I'll talk about the short-term exploration goal, which NASA, India, JAXA, the Europeans have which is to go to the moon via the Artemis mission. And to do that, I'm going to briefly talk about the moon itself, and then talk about the NASA's Artemis mission. And I don't think I'll get time, but I think this topic about moon dust, the moon regolith, is one of the most important things you have to worry about when we go and explore the moon. And then finally, for a few minutes, I'll talk about careers in space industry. So I'm not sure about what type of students are in this audience. It could be school students, could be college students. So if I make things a little simple, please do not think that I'm trying to deliberately dumb things down. I have no idea about the students in this audience. So let's.
Jaideep, most of the students are physics, chemistry, and engineering students. Most of them.
Okay, great. Thank you. Thank you. So let's talk about the trends and predictions in the global space industry. Okay, just to give an overview of the space industry for some of the students. It really all began when the Russians launched the Sputnik, and it started the space race between the US and the Soviet Union. And then it became a global organization with ISS, collaboration between US, Russia, Japan, Canada, and 17 other countries. And then the next step was the commercialization, and that's where private companies like SpaceX and Blue Origin have joined the fray. And they are going to provide a lot of services to the space industry. And then Sudhir Kumar talked about the satellites. So that's a critical infrastructure. Satellites are playing a big role in communication, navigation, and observation. And you'll see that the satellite industry will also play a big role in defense and scientific exploration. So what are the current trends? One of them is it's the increased commercial applications. So a lot of companies and agencies are using satellites from weather monitoring, climate change, and so on. They're providing a lot of information and a lot of data, lots of data to scientists across the world. But then you have new competitions. A lot of countries are now joining the space race. So you have China and other countries who are really ramping up the space program, and which actually increases the competition. And then you have the private companies like Elon Musk and SpaceX launching reusable rockets, which is actually going to reduce the cost of launching satellites, of going to outer space. Some of the recent trends in space technology. So first one, of course, I talked about reusable rockets. This first started with the New Shepard rocket by Blue Origin, but that didn't go to outer space, just went a few 100 kilometers and came back. But then SpaceX introduced reusable rockets, and they have been very, very successful. And that's what's actually reducing the cost right now. The second good trend is small satellites. We are going away from building huge satellites, but building a swarm of small satellites could be the size of a CubeSat, 10 by 10 by 10 centimeters. They are more easier to launch, they're more cheaper to launch. So that's a trend in the space industry. And then now you have the commercial space tourism. I know this started about 10 years ago, almost 10, 12 years ago. And we all thought that by this time that space tourism would take off. But, launching rockets is not easy, as everyone would say. So it has taken some time, but I would anticipate in the next couple of years, starting with Blue Origin, we are going to have a lot of commercial space tourism. Then you have this emerging space companies, right? I talked about SpaceX. They are really revolutionizing space industry. They're working on a mission to Mars. They have Blue Origin, and he's trying to make also new rockets and reusable rockets. And of course, it's connected with space tourism. We also have Virgin Galactic connected with space tourism. But there are a number of other small companies like Rocket Labs, which have come up and which are trying to build small rockets to launch small satellites into space. So a lot of private space companies have entered the fray. The space tourism, that is one thing where a lot of these companies are trying to join. So it's some of the pros of space tourism that if you are a space tourist, it's a once in a lifetime experience. It's a new destination to travel, right? We can travel anywhere in the world, but we haven't gone much to outer space. And then there's a lot of opportunities for research and development, like on the ISS. But the cons, it's very expensive, it is very risky, and then there's environmental concerns of pollution and impact on climate. We all talking about this number of satellites being launched into space by various countries, and that's great. I see students, even school students, building satellites and launching them. But look what's happening to the near Earth orbit. You have thousands of satellites in orbit around the Earth. And the debris from the satellites can cause major problems later on. So I know in the US, anytime you launch any satellite, you have to have a plan to deorbit the satellite. That's very important, even if it's a small CubeSat. So space debris is a problem, and that's one we have to keep an eye on. So what are the challenges facing the space industry? Of course, one is this cost. It is costly, it is risky, it requires investment. And then there's safety. You have to worry about safety because now you have humans traveling in these rockets. And the legal frameworks, as more countries join the space race, the legal framework that we have the so-called Outer Space Treaty, but it does not really help now that we are going to the moon, that we're going to go to asteroids. We're talking about intellectual property rights, who owns the moon or who owns an asteroid, you go onto it, and environmental protection. That's something it's something that I think space law could be a big thing in the future. So future opportunities, of course, we want to go to the red planet. We want to go to Mars because it's a better destination for us to create settlements on Mars, because it has an atmosphere and it has some gravity, and we think there is a subsurface water in the form of frost. But the problem is going to Mars, the travel time to Mars and the risk of radiation. So we have the test technology by first going to the moon. And that's why NASA and a lot of other countries want to go to the moon first, test the technology, and then go to Mars. Asteroid mining, I've been hearing about asteroid mining for about last 10, 12 years. And I know a lot of private companies which actually went under because they could not come up with the plans to go to an asteroid and then either bring back some of the material. But it is slowly changing, and I think asteroid mining will be a huge thing, and that's why a lot of the space companies, private companies, would be interested. This gives you some, I know there's a lot of information out here, but it gives you an idea how things have been changing. So if we look at the space market size, in 2010, it was $280 billion. In 2022, it's about $440 billion. But look at projection 2030, it's about $1,000 billion. That's a huge market. The other graph out here, which talks about the annual private funding, as you see from in 2010, it was only $1 billion in annual private funding. It's going to go to more than $20 billion in 2030. This is just private funding. Look at the number of countries with space agencies. Right now, we have about 70 countries having space agencies, and it will be increased to about 100 in 2030. Mr. Kumar talked about space startups. In 2010, there's 250 new space startup companies. In 2022, there's about 600 across the world, and they expect that to grow to over 1,000. So startup companies are also going to develop rapidly. If you look at the number of active satellites, right now there are about 4,800 satellites around the Earth. It's going to projecting is to about 15,000. And I think that's a lot. I know it's helping us with communications, with other issues, but having this number of satellites in around the Earth is going to be a major problem. If you look at the number of small satellites launched in 2022, about 1,700 satellites were launched. That's a great number. In about 4 years, it jumped from 300 to about 1,700. But look, by 2030, it'll be more than 3,000 satellites. But the main thing why a lot of startup companies, a lot of companies are going into space is look at the cost now. A satellite cost was, to build a large satellite was about, hundreds of millions of dollars. Now you can build satellites in a fraction of a cost and launch it to low Earth orbit. And that's why, because you have so many satellites, the number of launches have also increased from 75 in 2009 to 145 in 2022. And we expect that to 200 in 2030. So I live in a town called Titusville. You can see the map of Florida and the background. And I'm just across the river from Kennedy Space Center. And I see a launch almost one every week. That was not the case before. So I know the number of launches are increasing because I see one almost every week. And finally, the heavy launch cost to low Earth orbit has decreased rapidly. If you were using the space shuttle, you have to pay about $65,000 per kilogram of payload. Now with the Falcon Heavy, SpaceX has come down to $1,500. And with the new Starship, it'll be about $100. That's really cheap. What is the orbit for this primary focus of satellites? Now we are mostly in low Earth orbit, right? Because we have the space station, we are trying to have satellites in low Earth orbit. Previously, we were focusing on what is called geosynchronous equatorial orbit, about 22,000 miles above the Earth, and they were mostly communication satellites. But in the future, now we're talking about going to the moon. So in the future, a lot of the orbits will be either around the moon or far away from the Earth. That's the way the future is in terms of orbit. Some of the space tech trends and innovations in 2023, if you look at some of the trending topics, you have miniaturized satellites, advanced space manufacturing. That is a big thing, especially for students in engineering and even technicians. Advanced communications, space traffic transportation, propulsion, space mission, space mining, space data. And look at all these companies that have sprung up, and these are the trends in this year. And someone also talked about, how satellite technology is really the backbone of a digital world, whether it's GPS navigation, TV, communications, exploration, weather monitoring. As I said, there are about 1,700 active satellites orbiting the Earth. And I talked about the number of active satellites is going to go up rapidly in the next 10 years. So the three emerging trends, one of them is the products and services focused on orbital and suborbital space flights. And the main reason is the rocket launch cost, which is coming down rapidly from about $14,000 in 2016 to about $1,500 right now. And with the Starship rocket that SpaceX is building, it might come down to $200 or $100 per kilo. That's really low. So that's one trend. The second trend is technologically enabled products and services for space exploration. And the best example is 3D printing, additive manufacturing. So, manufacturing in space, that is a huge topic. But this 3D printing has really changed the way we are doing things all over the world. And so to give an example, if you look at in 2015, the number of 3D printed parts in one commercial plane engine was 19. In 2019, it went up to 304. In 2024, it's about 4,000 parts in one engine. In a Rocket Lab, I forget the name of the company, I think it's Rocket Lab, they built an almost 3D printed rocket. About 80% have been 3D printed. So 3D printing is one of the biggest thing in the market right now. And this gives you an idea, analysts estimate of the 3D printing market by 2030, about $100 billion. And then there are other relevant products as a result of that. So one is drones, using drones for deliveries in e-commerce. And that has reduced the price of delivering things around the world. And also quickly, can do things very quickly. So these are all the things that are being emerging as a result of the space industry. If you like the sector weights, industries, about half of them, half of the companies in space is industry. Then you have information technology. And if you look at the country weights, the US leads about 80%, then you have France and Sweden and then other countries. So this is the trend in space industry. It gives you an idea of where we are heading. But remember one thing, if you really want to explore space, explore the solar system, companies will not do it because companies work because they have to have a profit margin. So if you want to explore, if you want to go to other planets, you want to see what's going on in the universe, you rely on space agencies, you rely on ISRO, you rely on NASA, on ESA and JAXA. So what I talked about is about the space industry and what they can do. But I think that for exploration, for getting knowledge of what's in outer space, we still have to rely on the national agencies, but they can always outsource these companies to do a part of their work, whether it's propulsion, whether it's rocketry, or even building payloads. So now I'm going to just move on and talk about the Artemis mission to give you an example of a short-term goal for exploration. And this Artemis mission involves scientists, engineers, people in commerce, management, and so on. So this is a very good example of a mission that can involve anyone from sciences to engineering to media communication and business. This is a question I get all the time, and I'm sure people in ISRO and other agencies get. Why are we spending our money to explore? And these are some of the reasons why we're doing it. We're doing it to protect and understand the world. Climate change is a big issue. We need to understand what's going on. Inspiration and exploration, that's where all you students come in, because if we need our society or even the human race to really develop, we need to be inspired, we need to explore. Without that, we will be dead as a human race. We need to inspire the students. So by exploring space, we are inspiring students right from kindergarten all the way to postgraduate. As a result of the space race, we have new technologies being developed. answering unknown questions. The reason, people like us, humans, have telescopes and satellites as opposed to, say, apes, is because we are interested in answering unknown questions. We want to know, are we alone in the universe? We want to know, are there life elsewhere in some of the planets in the solar system? Answering on some of the unknown questions. As a result of exploration, we have a lot of international collaboration between countries. That was not the case before. And of course, long-term survival. We are being bombarded by small asteroids and meteorites every day, but there's a time when we have a big asteroid coming towards us and we need to figure out a way either to deflect the asteroid or do something to it, because if an asteroid, a large asteroid, hits the Earth, it could be catastrophic. So long-term survival. I'd like to show the quick graphic of benefits of space exploration. From digital cell phone technology, advances in heart pump, GPS, diapers, Velcro. Velcro was a result of space exploration, hearing aid and battery technology, and so on. I can give a couple of hours talks on the benefit of space exploration, especially the spin-offs. I can talk about the NASA spin-offs because I'm aware of it, but all the things that you see out here, whether it's climate change prediction, whether it's things in an ambulance or a car phone, and so on, were all a result of technology being developed by NASA and then spinning it off to small companies. So it goes on and on. So when someone asks me, why are we spending money to go to outer space? I have to tell them, look, apart from the reasons I talked about, there are so many applications, things that are better than lives, 100%. And the amount of money we spend going to space is negligible compared to even, say, making a movie, whether it's in Bollywood or in India and Hollywood. The amount of money we spend to space for going to space is very, very small. These are some of the surfaces visited by humankind and rovers. The only place we have been is onto the moon, but we have launched rovers, we have sent rovers to various places, including Venus, Mars, some of the moons of Saturn like Titan. We have landed on comets, on asteroids, and so on. And that's interesting that we can go and explore all these places because, as I said before, we are running out of resources on the Earth. And I'm not saying we should forget what to do on the Earth, but we should start thinking about what we can do for future, for our children or for our grandchildren, because the resources are being depleted. So we have to figure out a way, where can we settle next? I'm not talking about the whole human race going to the moon or going to Mars, but just start slowly. The places you can go are the moon or Mars. Then there are some places in a solar system where we think there is water. One of them is Europa. The other one is Enceladus. In Europa, we think there's more fresh water than on the Earth. So there are some very exciting objects in the solar system that we need to explore, that we need to really study. So the question comes is, why do you want to explore the moon right now? Why are we spending so much money to go to the moon? So we know that there's a lot of science yet to be done on the moon. I know the Apollo missions get back a lot of data, but there's a lot of science that we can do. It's a stepping stone to Mars. To go to the moon would take us about a couple of days at the most to go to the moon, but go to Mars with the most favorable configuration of the Earth and Mars will take us 6 months. And that also every 2 years we get that 6-month window. And then a major problem, which I think is the biggest problem we have, is a lack of technology to block the radiation as we travel from the Earth to Mars. To Earth to the moon is a couple of days, and we have the technology to protect the astronauts and the tourists. If you want to go to Mars, and there's so much radiation when you're going into outer space, we don't have the technology as yet to block the radiation. Unless we have that, I don't think we can go to Mars this quickly. This is my personal opinion. I don't think we're sending humans to Mars, not before, say, end of 2030s, or it could be even 2040s, just because We might have the technology to go over there, but we won't have the technology to protect the humans who will land on Mars. So it spurs new technologies, and we try to go and explore the moon. And of course, for me, as an educator, it has the potential to inspire a generation of engineers and scientists. So because I'm talking about the moon, I would like to give you a quick brief background on the moon, before I talk of the Artemis mission. So this is the Earth's moon. This is our natural satellite. We have had 24 human visitors. 12 have landed on the moon. There are more than 100 robotic visits. And these are some of the areas where the Apollo landers have landed on the moon. And here are some of the other robotic missions. The ones in yellow are the Russians and the Chinese. The Chang 3 over here is Chinese. And then you have the Apollo missions and the Soviet. The ones in yellow are the robotic missions. The one in red or pink are the humans, human missions. These are the folks which have landed on the moon and which have gone around the Earth. So, Apollo 11 was the first one which landed, but Apollo 8 was the first one which went around the moon and returned back with a landing. Apollo 13, as you know, had a problem, so they couldn't land on the moon. They had to come back. But all the rest, you had 2 landing on the moon and 1 orbiting the moon. These are some of the selected moons in the solar system with the Earth to scale. So this is the size of the Earth over here. Then this is the size of the moon compared to the Earth. These are the sizes of the moons of Jupiter. So as you see in this diagram, the Earth's moon is quite large compared to most of the moons in the solar system, maybe apart from Ganymede and Callisto and Titan. So it's quite a large moon that's orbiting our Earth. The other thing, and this is most of our school kids, I hate people memorizing numbers. Some of them you have to memorize because, like the constant speed of light. But I tell people to look at the relation. You remember that more. For example, if I'm saying that the diameter of the Earth is 12,000 kilometers, the moon is 3,000 kilometers, I look at the relation. I would say the moon's diameter is about 27% of the Earth. Same thing with the surface area, it's about 7% of the Earth. The volume is 2%. I can remember those numbers than those huge numbers that if you use the actual values. The mass, the moon's mass is about 1% of the Earth. The density is about 0.6% of the Earth. This is important, remember this. The density of the moon is less than the Earth, and that plays a factor in us trying to figure out how the moon was formed. The gravitational acceleration is 1/6 that of the Earth, which means that if you are on the moon, it's easier to launch rockets because the gravitational acceleration is quite low compared to the moon. So if you're on the moon, compared to the Earth. So if you're on the moon, you can jump a lot higher than you can do on the Earth. So it makes sense that in the future, if you want to go launch rockets to outer space or satellites to outer space, we have launch bases on the moon itself. They're a lot cheaper to launch. And again, also the escape velocity as a result of that is quite less than out of the Earth. So it's easier to escape the moon's gravitational field. So this is an idea of how the moon compares with respect to the Earth. If you just go outside on a night when you can see the moon, you can see 2 prominent features. One of the high lines, which is the craters. The other one is the Marias, which used to be called the seas, because the solid surface, the glazed surface of the moon, people thought there were oceans in the past. That's why they were called seas. Maria is a Latin for seas. But it's less heavily cratered, and the surface is younger than the rest of the, geologically younger than the rest of the moon. I'm going to skip this. But one of the important things which I think, and in our institute, we're doing a lot of work on the effect of lunar regolith or the lunar dust. The lunar regolith is nothing but a loose deposit of soil covering rocks on the surface of the moon. And the reason the regolith, or which is also called soil, it is a mixture of powdery dust and broken rock, and is formed by the impact of meteorites on the body's surface. The moon has almost no atmosphere. It does have a very, very thin atmosphere, very thin, but it cannot stop the meteorites coming on and hitting the moon. So it's impacted a lot, and that causes this regolith on the moon. And we're calling the regolith is actually the lunar soil. It refers to the finer fraction of the regolith, but some people just talk about the regolith as the lunar soil. So when I talk about the regolith, I mean in the vocabulary for geology, it's the soil. And why? Look at this picture. This is a spacesuit worn by James Irwin. He was on the Apollo 15 spacesuit. Before he landed on the moon, it was pure white in color. And as he landed on the moon and did some moonwalks, look at the color. All this dust, the lunar regolith, clung onto the spacesuit and changed the color. And this lunar regolith, if you look at it, it's very, very sharp. You cannot use your hands. You have to use gloves to work on that. So because it's so sharp, it can affect instruments. If you have this lunar regolith on your helmet and you try to use your gloves to wipe it, it will scratch the helmet. And if it enters your nervous system, it'll cause cancer. So this is a deadly dust, the lunar dust, and we have to figure out a way to mitigate that if we really want to explore the moon. I'm going to quickly talk to you about the formation of the moon, because I like to show this because this is the way science advances. You know, science is not the ultimate truth, but science is a way of telling you what is right as we know right now. I'm not saying anything that we say is the absolute holy grail. That is the reason, but we can always change, and that's the beauty of science. You know, we will change our opinions once we get hard facts, data to support it. So the formation of the moon, there were four hypotheses. The first one was a capture hypothesis, which says that the moon was formed far away from the Earth, and as it came closer to the Earth, it was captured by the Earth. The problem is, if we look at the composition of the moon, it's very similar to the mantle of the Earth. Chances of a body formed elsewhere having very similar composition to the Earth is very, very rare. Also, some people think that the probability of such an object being captured and being near the Earth at the right time is very small. So the capture hypothesis was thrown away. Then there was something called fast rotation. They thought that the Earth rotated very fast in the beginning, and as a result of that, a chunk of the Earth was thrown out and formed the moon. The problem with that is that the moon actually is a little younger compared to the Earth, a little younger. If it came from the Earth itself directly, then the age of the moon and the Earth should be the same. So that hypothesis, and also we have no evidence that the Earth was rotating so fast in the past. Something called co-accretion. We thought that the moon and the Earth were formed from all the same material going around the sun, and this material combined to form the Earth and the moon. But if that's the case, then the density of the Earth and the moon should be very similar to each other, because it was formed from the same type of raw material. But we know that the density of the moon is less than that of the Earth. It has a lot of less iron compared to the Earth. So that hypothesis was thrown away. And finally, the one which actually compares well with observation is the collisional hypothesis, where a Mars-like object billions of years ago came and hit the Earth at a glancing angle, stripped up the mantle, and this mantle material then formed the moon and orbited the Earth. This explains why the density is a bit less, because it's not the core of the Earth which was impacted by the mantle of the Earth, and a lot of other factors also. So we are very happy so far with this theory right now. This is a computer simulation of what would happen when you have a glancing blow to the Earth. So we're happy with this, but if we get better data, we are going to change our ideas. That's the beauty of science. I like this video. It's a minute and a half, but it just talks to you about the evolution of the moon. It's about a minute and a half, but gives you an idea why the moon is as it is right now. And this was from data that we got from the lunar LRO mission. But in the beginning, the moon was molten lava. It was cooling down and solidifying, but it was just lava. And remember, the moon has no atmosphere. This is about 4.5 billion years ago. And then we had this huge impact near the south pole of the moon about 4.3 billion years ago, which formed what is called the Aitken Basin. You can have a look at the moon map and look at the south pole. There's this big area which is called the Aitken Basin. Then we had a time of heavy bombardment. Of course, the sound that you're seeing out here is cinematic license, just for effect. But you had heavy bombardment about 4 billion years ago. And that bombardment helped the formation of the Maria, because what happened was the crust was formed, but when this bombardment, meteorites came and hit the crust, it cracked the crust, molten lava seeped out, solidified, and formed what we call the Marias right now. So that was about 4 billion years ago. But compared to the highlands, which are heavily cratered, the Marias are a bit younger. And then there was this era of intermediate cratering about 3 to 1 billion years ago. And that formed all the craters that we see on the moon right now, even on the Maria. So that's the moon as we see right now. This gives you an idea how the moon was formed. Finally, if you really want to go to the moon, we need water. We need water to get oxygen, to breathe. We need water to survive. So quickly, I'm going to talk about a search for water. The Apollo astronauts brought back lunar samples. And at that time, in the 70s, late 70s, early 70s, when we looked at these samples, we did not find good traces of water molecules in them. But in the early 90s, when the technology became better and we looked at these rocks again, we did find traces of water molecules in these rocks. But the water molecules that we find is not exactly like the water that we have on the Earth. If you look at the levels of the deuterium isotope, which is a rare version of hydrogen on the moon, it's twice that of the Earth. And that's the result is because the water on the moon, we think, came from comets. And it's not like the water that we have on the Earth. The Chandrayaan mission, that really was a game-changing discovery, because what it did was it reflected infrared radiation from the surface of the moon. And if you had water molecules or hydroxide molecules, OH, it would absorb some of these radiation. That is shown in blue on the right. On the left is just simple infrared reflection, but if you take into account the reflection being absorbed by water, that's what you see. And look, there's so much water molecules on the moon. And that was the first time we really made that discovery. The technology a few years ago was such that it was difficult to distinguish between an OH molecule and a water molecule. But now the SOFIA is an airborne infrared observatory, and it had looked at the amount of water on the moon. And their technology was good enough to detect actually water molecules as compared to hydroxide molecules. But look at the amount of molecules they found in the crater. It's very little. It's just equivalent to a 12-ounce bottle of water, one small bottle of water. So it's not much, there's not much water in the moon in that sense over the surface of the moon that you can really use it to drink water or to get oxygen out of it. Where we get this water is near the south pole of the moon. In the south pole on the moon, on the crater floors, we have seen water. And we think this water came from comets which bombarded and hit the moon years ago. But the moon's axis is such that it's tilted very little. So on the south pole of the moon, especially beyond the floors of the crater, very little sunrise reaches those crater floors. So if a comet came and crashed, that comet ice still exists. And that's where we think there's a lot of water in the form of cometary ice in the south pole of the moon. And that's why everyone wants to go to the south pole of the moon, whether it's NASA or ISRO or JAXA, the European Space Agencies, is because we need access to water in those flights. So we don't have direct evidence that there is this cometary ice, but we have a lot of indirect evidence. But unless we go there and find out, we won't know. And again, these are just some, the blue represents the ice locations on the South Pole and the North Pole. There's a lot more near the South Pole. So that's where we want to go. And I said water on the moon mostly came from comets, but also, the water molecules that we're seeing on the other parts of the moon, they came from the interaction of the solar wind. The solar wind is nothing but a stream of energetic particles, charged hydrogen ions. And the lunar rocks contain by percentage about 40% oxygen in the molecules of the rock. So what happens is when these hydrogen ions come and bombard at the speed, almost at the speed of light, it breaks the bond of these molecules which has oxygen, and oxygen atoms become free. So now you have free-flowing oxygen atoms and hydrogen ions, and they form hydroxide, OH, or water molecules. That's why we think that there are water molecules on the other parts of the moon. In the South and North Pole, it's cometary ice. But here, this is where they come from. And that's not enough water for us to really survive. I'm going to show you this because this is going to be a major issue in terms of who owns what part of the moon. These are called areas of the moon near the South Pole craters, where there's some elevation. So think about it. If you want to make use of the ice on the floor of the craters, and if you want to create a base or a settlement on the floor of the crater, very little sunrise reaches it. So we cannot use any power from the solar light. We have to use nuclear power, and that's dangerous. So the way to get power from the sun is to be in areas where you have elevations. And these are called the peaks of eternal lights. And that can be a cause of problems when different countries go to the moon. Okay, so suppose India comes and lands and forms settlement near this peak of right. Another country forms near B. Who owns it? Is it theirs? This is going to be an issue. This is where space law is going to be a big thing in the next few years. Because you have to come up with a treaty with some kind of a legal framework about who owns what parts of the moon. So the peaks of eternal light is going to be an important thing because that's the places that we are going to go and have settlements. So I talked quickly of the moon. I still have a few minutes left. I'll talk quickly about the Artemis mission. So we are doing the Artemis mission because we are going to prepare for Mars. We're going to create the technology, test on the moon to go to Mars. And how are we going to go there? So we're going to go there by building exploration ground systems with our rocket launches, launch towers, a new rocket called the Space Launch System, which right now is the most powerful rocket in the world. But once SpaceX has a Starship rocket, that will be the most powerful rocket. We also have Orion, which is the module which will carry the astronauts to the moon. All these have been developed. What is not being developed is this Gateway, which is a small space station which is going to go around, the moon. And the idea is that we are going to launch from the Earth, dock to the Gateway, and from there we're going to land onto the moon. That's the plan. It's easier to do that than going to the moon, slowing down and landing onto the moon. This is a better approach, but we don't have the funding as yet for the gateway, just the funding for the first part of the gateway. Lunar landers, NASA has outsourced this to private companies, and SpaceX has won the contract for a lunar lander to take humans, land humans onto the moon. There are going to be there are going to be other landers which will carry experiments, but these human landers are being developed right now. And of course, we have to have a new spacesuit. We have developed a new spacesuit because the spacesuit we have right now is not good for exploration. Here's the rocket. I don't want to go too much into detail, but I'll show you a very quick video to show you how complicated the rocket is. But it's a large rocket. It's larger than the space shuttle. It's comparable to size to the Saturn V rocket. And I know most of you may not have seen the Saturn V rocket, but it was a large rocket. I'm sorry that I have to give the comparison in terms of US landmarks. So in this graphic, we have the SLS rocket in terms of the Statue of Liberty. Just shows you how big that rocket is. The main power from the rocket to lift it away from the Earth to escape the Earth's gravity is what is called the solid rocket boosters. They're about 17 stories tall. They provide most of the power that you need to escape Earth's gravity. So the solid rocket boosters are on both sides of the rocket. And the one thing about the solid rocket boosters, once you start igniting it, you cannot stop it. It'll start burning. As opposed to liquid fuel, where you can control the amount of fuel that will go to an engine. So that way, solid rocket fuels boosters are kind of dangerous because you can't control it, but it provides most of the thrust. This is the rocket engine that have been used. These are the space shuttle engines that we use, and they run for about 8 minutes. So look at the operating temperature range. They go all the way from -400 to +600 degrees Fahrenheit, because you have to have that operation range, because when you have liquid hydrogen or liquid oxygen, they're very, very cold. But once you ignite those gases in the combustion chamber, the temperature goes to 5,000, 6,000 degrees. So it has to have that operation range. I like this video because it shows quickly about the whole rocket itself. There's so many components to it. It's self-explanatory. So that's the SLS rocket. On the top, you have the Orion spacecraft, which has a launch abort system. And then we have the other parts of the rocket. We'll show you part by part. So that's the launch abort system. It's a smaller rocket on the top. In case something goes wrong during launch, they can take the Orion module and move away from the main rocket and splash down into the ocean. That's a service module which will contain the life support system for the Orion. It's the different adapters that you have various parts of the rocket. This is the interim cryogenic propulsion stage. Again, different adapters for different parts of the rocket. It gives you an idea how big those adapters are. This is the liquid oxygen tank to power the engines. Again, shows in comparison how big they are compared to a human. This is a tank between the oxygen and the hydrogen tank. Here's a liquid hydrogen tank. It's an idea of the scale. And here's the engine section, which has this shuttle engines. And here are the engines. And finally, you have the solid rocket boosters. They're being tested in Marshall Space Flight Center. So this gives you an idea how impressive this new rocket is. And if you're an engineer, I'm not an engineer, my background is in astrophysics, but my hat's off to engineers because they come up with these great techniques and engineering feats. Whenever you have a human-rated mission, you have to be very careful that you test everything very well. You cannot afford things to go wrong during a launch. Here's an example of the, I think it's the hydrogen tank being tested to see how much force it can withstand during a launch. So they push the oxygen tanks to the maximum, more than they could face during a rocket launch. The vibration and the shaking and everything. So they use exact replicas of the hardware. This is at Marshall Space Flight Center. NASA has 10 centers. Kennedy is for launch. Marshall is for propulsion. That's when they're testing this tank. So they want to verify how strong the SLS hardware is. So they kind of go through a lot of tests until that hardware fails. So they can know the limit of how much you can go. So they apply forces much stronger than what you expect during a launch. But look what happens when you do that. It pops up like a soda can and twists. But this will never happen because you're never going to experience it. But just to give you an idea of what testing they have to do, you have to keep on testing and testing and testing. This is the Orion module, which will carry the astronauts. So you have the crew module carrying the astronauts. You have the launch abort system. You have the service module, which has the power generation, thermal control, and everything. Here's an animation of the Orion capsule. It was built by Lockheed Martin. It will carry 4 astronauts. And you have glass cockpit displays, touchscreen displays. So this is the most important thing, the radiation shelter. So if there's a dangerous solar storm, you can be safe. Here's the environmental control and life support, the oxygen that you need, the humidity, the right temperature, right pressure. It's a lot better than the Apollo module that went to the moon and carried astronauts. You have an exercise machine and a water dispenser, which you need to exercise because in outer space, when you have low gravity, your bone density decreases. Of course, you have a laboratory. You don't have to worry about wearing diapers now. You have a laboratory that you can go to space. If you're in space. So that's the Orion system. I talked about the crew launch abort system. So I'm going to skip that slide. The gateway, this is something that we are lagging behind because of lack of funding. The gateway is nothing but a platform, a small space station orbiting the moon. And the idea is that we are going to launch from the Earth, dock onto the space station. From there, a human lander will take us back to the moon. So it's going to serve as a test bed, a technology test bed for Mars. It's just a place, a halfway place that we can use to go to the surface of the moon. It will include living quarters for astronauts, for experiments and everything. But right now, we only are doing the first part of the module because of lack of funding. And the final version of this Artemis mission calls for proposals for landing the humans from the gateway onto the moon. And NASA sent out a request for proposals from companies. Blue Origin gave one proposal, Dynetics gave a proposal, and SpaceX gave a proposal for the human lander. NASA chose SpaceX for the Starship rocket. So the Starship rocket is being built. I don't know how many are following it, but they tried to do a test launch a week ago. And actually it kind of exploded just after going beyond the launch pad. So now there are a lot of issues going on with environmental agencies into the fray. They have stopped launching of Starship for some time until they figure out what's going on. But this is important to NASA, right? Because we need the Starship to ferry astronauts from either from the Gateway or from the Earth to the Moon. And if the Starship is not ready in time, then going to the Moon, sending humans to the Moon will be delayed a bit. So we have to wait and see. I'm going to give a shout out to some of my students in university. They have worked on a project which is actually called, it's like a small box, a CubeSat with cameras on all 6 sides. These are all done by undergrad students. So what the idea is that there is going to be a unmanned, uncrewed space or a rocket going to spacecraft going to the Moon end of this year, called the Lunar Lander, Nova C Lunar Lander. It's going to carry this experiment built by the students. And what it's going to do is that before the lander lands onto the Moon, it's going to, it has its thrusters, so it's a controlled landing. Before it lands, it's going to eject this CubeSat, this box. It will free fall onto the Moon. It will land onto the Moon's surface. It does not matter how it lands, what orientation, you have cameras on all sides. It's going to take a video of this lunar lander landing on the Moon and send it to the Earth. All done by students. And I supported them to do their experiments with the Blue Origin to demonstrate environmental survival. So I hope that this their CubeSat gets launched at the end of this year. And if I do get the video, I'll send it to you guys so you can have a look at it. These are, NASA has selected all these areas for the human missions to the Moon. These are all this peak of eternal lights. And they're based on a number of factors: proximity to the South Pole, continuous sunlight for about 6 days, a gentle slope. You don't want a very steep slope. That will be dangerous for rovers and the astronauts. So these are the landing sites that NASA has built. Spacesuits. These are the spacesuits being used right now, and they're mostly used for spacewalk, but not for walking across rocky surfaces. Look at this video of astronaut on the Moon, and look how he stumbles by trying to pick up things because the spacesuits were very rigid. So that could cause a problem because you don't want the spacesuit to tear by crashing, by hitting the Moon's surface that way. So they come up with a new spacesuit which is modular, so it can fit in different people, man and woman. 2 types of spacesuit. One is when you're on the Orion spacecraft, and the other one is when you are, outside on the Moon and trekking and exploring the Moon's surface. This gives you an idea of, sorry, hold on, of how this is a prototype. This is not the actual one. This is a prototype, but this gives you an example of how the spacesuit is compared to recent spacesuits. This is only for launch and re-entry, and this is red in color, orange in color because it can be sighted very easily. But this is the other spacecraft where you actually have to step into it, the other spacesuit. But it's modular. You can have different types of gloves, different arms. But the best thing is very flexible, as they'll show by that event. They look like the ones that are used by astronauts right now, but there's more mobility. See, can have different parts of the spacesuit, and depending on the size of the person, and of course, if we go to Mars, we need to have a better spacesuit. This was a spacesuit which was showcased just a couple of weeks ago, a month ago. The Artemis 3 spacesuit. This will be worn by the astronauts. Remember, the color out here is black, but this is, I think, for artistic things. If you are on the Moon, you do not want to have a black spacesuit because that is going to absorb the heat. So you want the white spacesuit. So when the astronauts really use the spacesuit to land on the Moon, it's going to be white and not black. But this is just for display. Here's the helmet, which is going to have headlights and also a mount for a high definition camera. So that's Axiom Space has been developing this. this spacesuit. And where are we going? So the first space, Artemis 1 was launched, I think was last November. The Artemis 2 will carry the first humans that will not land onto the moon, but they'll go around the moon and come back. NASA has selected 4 or 5 astronauts. Out of them, 2 of them will go in this Artemis 2. Artemis 3, which I think will be in the end of 2024 or maybe even 25, is actually going to go to the gateway and then land onto the moon. This is the timeline right now, but everything is going to slip because of funding issues that every agency goes through. I'm going to skip something because of lack of time, but here is every time you launch a new rocket, you have to do what is called a dress rehearsal, and you test it. So as I said, I live in Titusville. This is some of the pictures I took from across the river from where I live, which shows the rocket on the launch pad. The bottom right shows the 2 launch pads that NASA has for manned missions. One is the SLS, the other one is the SpaceX, the one in black. So they had to do a number of tests. The first dress rehearsal was a problem because they had a hydrogen leak. And if you have a hydrogen leak, you do not want to ignite the engines. Also remember, this is in Florida. You have a lot of lightning. Look at the 2 pictures onto the left. There were 2 lightning strokes. The towers that you see, the tall towers next to the launch pads are lightning towers. All launch pads here have the lightning towers because we have a lot of lightning. And they are taller than the launch pad, so they attract the lightning. And you can see pictures, superimposed pictures of 2 lightning strikes. But thank God we had the launch, the towers. So the first attempt was a problem because of the hydrogen leak. The second attempt, we still had again a hydrogen leak, and we had to stop the dress rehearsal. And then the third attempt was something else. The third attempt was delayed because we had a huge hurricane. Look at the size of the hurricane as compared to the size of Florida. It covered the whole state. And it was a very powerful hurricane. It came, as you see, on the west coast and went through Florida. It went above our area, above Kennedy Space Center. By the time it came to the Kennedy Space Center, it was category 1. But when it hit the west coast, I had my colleagues staying over there. The storm surge was so much that the water level came to the 2nd floor of apartment complexes on the ocean. There was a lot of destruction. So of course we couldn't launch, right? Look at the path of that hurricane. It was between the 2 launch pads, the SLS and the SpaceX launch pad. And NASA had kept the rocket on the launch pad because they didn't expect the hurricane to be that powerful as it came towards Kennedy. But in spite of that, it experienced very high winds, very close to the limit to which a rocket can withstand. But we were lucky nothing happened to the rocket. And finally, there was the actual launch was at 1:48 a.m. on October. And here's some pictures of the launch. I don't want to go through all these things because you can see them on YouTube. All these video launches from YouTube. These are beautiful pictures taken by photographers in this area. I want to just show you 2 quick videos we took from our area. This one is a launch. Just take it from a phone camera. But this is during the night, and it actually lightens up the whole. It makes it almost daylight. So that is one quick video taken from my colleagues' home across the ocean, across the Indian River. This is the actual launch from, and this is sped up. That's the Indian River Lagoon. That's Kennedy Space Center. And look how bright the sky becomes as a result of the launch. I'm going to skip some of these videos because it's a lack of time, but you can go to YouTube and look at all these videos. But I like this video because there was a camera in this Artemis mission in the Orion capsule, in the solar arrays, and it captured, look out here, Earthrise as seen from the Orion capsule. This is not Photoshop. This is a real sped up video. And you can see the Earthrise. You can see how blue the Earth is. Well, we see a lot of whites because of clouds, but That's the color of the Earth as seen from the Orion capsule near the moon. And of course, it went around the moon and came back, and the Orion capsule then jettisoned, and it landed on the Pacific Ocean with parachutes. We had one from one of our institutes, a professor who was there in the ship because he was analyzing the wave dynamics to see how far, if there are huge waves, where will the actual capsule be. So he was there in the ship. But look at that, the Artemis mission slowed down from 25,000 miles per hour, the capsule, about a dozen times faster than a rifle bullet, to 300 miles. And the heat shield reached about 5,000 degrees. The capsule heat shield, because it went through the atmosphere, twice the temperature of Mountain Mount. So that's a picture of the final landing of everything went very well. I'm going to skip. I don't have time to go through this, but lunar dust is a major problem. And this is one the Apollo 17 commander said, I think dust is probably our greatest inhibitors to a nominal operation on the moon. I think we can overcome other physiological or physical mechanical problems except dust. And again, here are pictures of the space suits after they have walked onto the moon. Here are some of the problems. You have increased heat transfer. It can rub and wear down surfaces through friction. It has a negative effect on coatings, especially when you're sealing equipment in space, lenses. Possible damage to astronauts' lungs, nervous and cardiovascular system, and of course, spacesuit arcing, arcing due to exposure to the space environment, electrostatic arcing. So these are some of the issues that we have to worry about before we go to the moon. Venkata Giri, do you have 5 minutes to talk about space careers, or do you want me to stop here?
No, I would request you to continue, Jaideep. Please,
Okay.
please continue. Please
Okay.
continue.
So I talked about the Artemis mission. Again, as I said, if you want to explore the moon, you want to explore the solar system, you have to rely on agencies. There might be outsourcing to private companies, but no private company will spend all that money and take the risk if there's no profit involved. So, I think this is a great time for students to be in this topic of space, but space is very, very broad. So one of the career options, space career options, and it might vary from country to country, but if you're a scientist, want to be a scientist, astronomy, astrophysics, atmospheric scientist, plasma physicist is what we're looking for. If you're in engineering, we want aerospace engineers, computer hardware engineers, electronics engineers, mechanical engineers. But remember, a lot of the work are done by technicians and not so much by engineers. Technicians play a vital role in the space industry. And I know, at least here in Florida and the US, I'm focusing a lot of technician training because we are lacking that. And companies say that the people who come and join their companies do not have the actual practical knowledge. So if you're a technician, we need aerospace engineering technicians, avionics technicians for aircrafts, meteorological technicians to help with weather balloons and releasing balloons to test the weather before a launch. And then you forget about media and communications. This is also open to the art sectors. We need good photographers, producers. Public relations specialists, that's very important. Every mission should have a good public relations specialist and good technical writers. We need to tell a story to the general public. And this is where scientists and engineers, we lack a bit in this field. We need to tell the story in such a way that is exciting, that's not complicated, and let the public absorb this information and get excited. And for that, we need good technical writers. If you look at some of the articles that have come up in the websites and newspapers, they are really terrible, really terrible. So we need good technical writers. And I think that's one focus we need to worry about if you want to have a career in space. So how do you prepare? So if you're in high school, in standard, say 9, 10, 11, and 12, you should take all your math and science courses, because even if you want to take a science or engineering degree, you want to take the math and science courses that are being taught in the schools. That's very important. And once you're in college, if you want to go in space sciences, then you need a solid foundation in physics and math. I'm going to talk to you right now about space sciences, but then in a few slides, I'll talk to you about the technology that NASA requires. Because my background is in astronomy and space sciences, I really cannot talk much about what you need to study in terms of engineering, but I can tell you what are the requirements by NASA and space agencies, so you can focus on that. But for space sciences, if you want to have a good foundation in physics and math. You take courses in electricity, magnetism, atomic and nuclear physics, thermodynamics, statistical mechanics, and even quantum theory. Also, if you want to be a planetary scientist or do biochemistry, then you need to take courses in geology or chemistry. So it all depends also what you really want to do in space sciences. It could be a variety of things, but you have time to think about it as you join school. But start thinking about it when you're in school, because that gives you an edge on other students. In college, also recent years, supercomputers are being used by astronomers to simulate processes that was difficult to study. If you want to figure out, what happened at the beginning of the universe, how did galaxies form, you need supercomputers. So astronomers, especially if you have a good background in computer science, that will help you in theoretical astronomy. Again, I cannot emphasize this more. You have to have a good ability to read, write, and communicate well with people, often across cultural boundaries. This is very important. Do not neglect courses in writing in the arts and social sciences, because if you want to be a successful scientist, you have to know how to write proposals. To write proposals, you need to have good fundamental knowledge of writing properly. I received so many applications from students, and I can look at their essay and I can figure out either their passion for space or whether they have the ability to compete with other students in terms of writing and winning proposals. So I again say this is important to not neglect these. Just to give an idea of some of these space sciences in the state of Florida, I don't have time to talk about the whole nation, but I work with all the universities in Florida. So I can tell you in Florida, the major research universities are listed over here. University of Florida, Central Florida, Florida Institute of Technology, and Embry-Riddle. They have thriving astronomy and aerospace engineering courses. And there are other programs in astronomy and space sciences. But if we look at different universities, for example, this one I think is University of Florida. They give bachelor's degrees and master's degrees in in astronomy and master's and PhD in astronomy and astrophysics. If you, and here the roster's research focus: extra solar panels, cosmology, instrumentation, stars formation, theoretical astrophysics. If you go to the University of Central Florida, their focus is more on planetary sciences. And there is the Center for Lunar and Asteroidal Surface Sciences, where they study a lot of the interaction of the lunar dust with spacesuit and instruments. So if you want to do planetary sciences, UCF is a good place to go. These are some of the research focuses: astrochemistry, planetary rings, microgravity. We have UCF has what is called the Stephen Hawking Center for Microgravity. The Florida Institute of Technology is a lot of aerospace, physics, and space sciences. Again, bachelor's, master's, and PhD in black holes, AGN, massive stars, and also human space exploration. Then the Embry-Riddle Aeronautical University, though it says aeronautical, they do a lot of astronomy, astrophysics, and engineering physics. These are the degrees they offer. And these are the research focus from hot stars to exospheres of other planets. So that is what science is, because I'm very familiar with that. But I'm going to quickly end by showing you some of the technology that NASA is going to use. They have this taxonomy for this technology. So you have propulsion systems, any type of propulsion system, nuclear, chemical, solar, flight computing and avionics. These are all these topics that is important to NASA and space companies. Aerospace power, robotic systems, communication, navigation, orbital debris tracking. Again, that's very, very important. Human life support, if you're worried about manned missions or crewed missions. Sensors, instruments, entry, descent, landing, software modeling, simulation. So you're talking about engineering, you're talking about computer science, material science, manufacturing, thermal management systems, of course, that's important. Air traffic management for aviation, guidance, navigation, and control for satellites. And for the Artemis mission, it's a manufacturing technology which will be a key enabler for sustainable lunar operations. So we're talking about material structures, mechanical systems, manufacturing, structural dynamics. These are all is important for the Artemis mission. Manufacturing processes are talked about 3D printing and additive manufacturing. That is important. I'm going to give you all the slides so you can have a look at it later on carefully. I'm just quickly going through it. Intelligent integrated manufacturing, integration of sensors, and analysis and measurement of the data that you get. That's important. Electronics and optics manufacturing process. So, vacuum tube, nanoelectronics, flexible electronics, precision optics, that's important. Nanoelectronics, sustainable manufacturing, and then non-destructive evaluation and sensors. This is where a lot of the research is done at the Kennedy Space Center on non-destructive evaluation and sensors. So these are some of the things that you need to know if you want to be interested in what NASA is doing and what the space companies are doing. I'm sure even at ISRO, these are the topics that are going to be very, very, very useful for the students. So I'm going to stop here because I know I've taken a lot of your time, and I went through a lot of information, but I'm willing to give the information to the PowerPoint to Venkata Giri, and he can share it with the students. There's nothing, no information out here which is not public knowledge, so I have no issues giving it. I'm going to stop here. Do you want me to take some questions, Venkata Giri, or just stop here?
Jaideep, that's a very, very exhaustive presentation. Thank you so much. I'm able to see the pains that you've taken based on our request. Some of the pictures were really, really breathtaking. Thank you so much. Jaideep, can I send your email ID to the attendees and participants?
Yes, please do. And if you're writing to me for the please tell me that you were at this talk. So then I'll reply back, because I get too many emails and
I understand.
Junk emails.
I understand, Jaideep. Again, on behalf of all the participants, I take this opportunity to thank you so much. Thank you again. Ladies and gentlemen, I have pleasure in inviting Dr. L.K. Sharma to make a very interesting presentation on the requirement of multidisciplinary talent for a career in space. A few words about Dr. L.K. Sharma. Dr. L.K. Sharma was still recently the president of Indian Ceramic Society for 2021-2022. Dr. L.K. Sharma is currently the chairperson of the India chapter of the American Ceramic Society. He is the CEO of Mahamana Ceramic Development Organization, member of International Ceramic Federation, visiting professor of Delhi Technical Campus, Greater Noida, visiting professor of PDA College of Engineering, Kalaburgi, and honorary director of Agni Smoke Private Limited, Bengaluru, and a fellow of Indian Institute of Ceramics. With those words, I take pleasure in requesting Dr. L.K. Sharma for your presentation. Thank you again,
Yeah,
Dr.
yeah,
L.K.
yeah.
Sharma.
Thank you, Venkat, for great introduction.
Thank you.
Yeah, good evening to everyone. And after wonderful inauguration, wisdom words by Mr. Sudhir Kumar, and then presentation by Professor Jaydeep. And I think all the people I will just quickly, I will go that because my topic is what is the scope for the engineers, signed BSc graduate, MSc, all those people and this thing. So Professor Jaydeep has talked about space tourism. So there is also a scope for research. And in last 10 years, our satellites means launch numbers have grown almost 50 times. There is lot of scope for the research and for engineers. He has covered challenges also, that challenges to go to space. So cost reduction in some cases he has shown it has reduced drastically, and we are planning to go to the Mars. So we need a space station on the moon. So that he has spoken. He has talked about mining on the moon. So mining engineers also may be having scope there. So all those things, and he has given fantastic details about comparing moon and earth with all these things. And you see that when we go to space, even suits are important. So I was trying to analyze. He was talking that lot of dust and that is speed, all that. And when space shuttle goes, all that. So speed also something, if I remember, 25,000, 26,000 miles per hour. So that all the things, wear and tear, wear resistant properties are important in all the aspects. So that is important. So we have lot of scope for engineers, graduates in science, for their careers. They can develop in their career in this. So now I will request Venkat to share my presentation, please.
Yeah, sure.
Or you want me to share?
No.
Okay.
We are
You
doing it.
please. Yeah.
Started. Oh, yeah.
Yeah, full screen.
Yeah.
Can you make full screen?
Yes. Yeah.
Yeah.
Yes,
Yeah.
Dr. Sharma ji, please.
Yeah. So I'll be speaking on that current trends in global space exploration, and this thing, what are the scope for others? This thing. Next slide, please. Space exploration, that industry needs, as Professor Jaydeep also spoke, physicist, astrophysics, chemist, all electronics engineer, all those kind of, so multidisciplinary talents are required. Next slide, please. Now, space and human, if we talk, law of science made the invention of rockets to travel to the space. Human, as we said, we are eager that we want to even have tourism in at moon. So humans' hunger created the need to explore the space. I can say almost maybe still maybe 5 or 10%, 5 or maximum 10% we would have explored. 90% is still unknown. So we need to explore that space. And all this, our hunger and our exploration means eagerness, all this word came up, that is space exploration. Space is a boundless three-dimensional extent. This thing is space has millions of mysteries. As we have seen a lot of videos in our last presentation, means is someone that astronaut trying to pick up something. We have health challenges. We have bone density. Bone density goes down when we are in the space. So all those things, for all those things, technological developments are required. And we have a lot of scope. Next slide, please. Now, when 50 years after this President Obama has told in 2010 that 50 years after the creation of NASA, our goal is no longer just a destination to reach. Our goal is the capacity for people to work and learn and operate and live safely beyond the earth for extended periods of time, ultimately in ways that are more sustainable and even indefinite. So we need water, all that infrastructure also there. And so we have started thinking about for the water, for the oxygen, and when we have done some research on the moon, we could find that some as to molecules were there. All these things are taking place. So we are beyond of reaching to the moon, and in fulfilling this task, we will not only extend humanity's reach in space, we will strengthen. He has told that we will strengthen America's leadership here on Earth for the space. Next slide, please. Yeah. Space and human, when we talk, advanced developments of exploration systems are there. As we have to reduce the risk, we have to take care of this safety, lower life cycle cost is a hidden cost, validate operational concept for future human missions for each beyond each orbit, support that robotic missions of opportunity to characterize the means destinations for human exploration. There are strategic knowledge gaps. There are strategic means knowledge gaps about the knowing about the space, about that dust, all those things that is there, that what is the velocity of that, what is the what kind of wear abrasion it creates, all this thing is required. So expand, we can say, human presence into solar system. That, and from there we are planning to go to the Mars. So then we have started thinking that in next 10 to 20 years, we should do advanced exploration. So science is required, engineering is required, and then humanity considerations are required to go to the Mars. So we have started doing all those kind of advanced research. Next slide, please. Yeah. Now we spoke that there's a lot of other challenges even that cause, which this was the next slide. Next, previous slide.
Previous one, yeah.
Yeah.
Earlier. Go. Just a second.
Yeah. So
There is a delay. There is a slight delay.
Yeah.
Yeah.
So even Professor Jaideep also that there are challenges. So going to space itself was a challenge and still is a challenge. Survival in that Humans evolved on Earth's surface. Space is a very different environment. Water, oxygen are the challenge there. Then staying and working, doing research, doing mining, going to different places, health, medicine, all these are the challenge, and cost and safety are the challenge. And then I remember when that Rakesh Sharma in '84 went to the space. I am fortunate that our teacher was there, Professor Ramchandra Rao and Professor T.R. Anantharaman. They used to teach us the material science in MTech. And that time when Rakesh Sharma from Russia went to the space, then they have done some, they came back and we were not having even TV in Banaras. So we were listening their interviews on the All India radio in our hostel. They have tried to develop that silver germanium alloy that time. I don't know what happened later on. But then they had processing of ceramics in space. So touring is also our next target. So lack of infrastructure is a challenge. Then biggest challenge is returning back from the space to the earth is the biggest challenge, which we remember that Kalpana Chawla has faced. So where resistance was the biggest challenge when they were coming back. So coatings are required. Next slide, please. So when all these things, and when you have heard our previous presentation, we need aerospace engineering to enter to the orbit. We need design engineers, so industrial engineering. We need sensors, we need signals. So we need electrical and electronics engineers to design software and hardware, all those, work out all that strategies for launch. We need computer engineers. We need to choose the right metal, to choose the right alloys. We need the metallurgical engineers to do research in science. We need material science. We need physics. We need chemistry to provide wear-resistant coatings on the shuttle surface and on the engine parts, on bearings, all those things. Advanced ceramic components are required. We need ceramic engineering. This is just, and Professor Jaideep has covered a lot of branches of engineering, lot of branches of science, all that specialization in science. So this is just a brainstorming. So we need lot of field experts. So there is a lot of scope. So next slide, please. Now, when all these things, engineers are required, space shuttles, although cost have gone down as we spoke in previous presentation. As of now, the global space economy stands at $450 billion. Ever since the exploration of this started in the space industry is growing. Many startups have come up in public also, private also, and exploiting potential sources. A lot of people have started this. With the participation of more private players, the global space industry is likely to reach almost $1 trillion annual revenue by 2040. This is the Pawan Kumar, the ISRO chairman, has spoken about this by 2040. Next slide, please. Lot of that startups have come up. As the Blue Origin name came in previous presentation also, SpaceX, Virgin Galactic, Agnikul, Skyroot, all this, Dhruva, Galactic, all these startups we have seen, we have listened, and they are working very seriously on this space business. Next slide, please. Now, if we see that big 1 trillion we spoke, India contributes approximately less than 2% to the space economy of that 1 billion, this thing, which is 20 times less than that of US. Reason that funding is the challenge, cost is the challenge, and we have to, for so many parts, for so many means technologies, we have to depend on others. So that is the in India scenario. Next slide, please. Thanks. Yeah. Now, if we compare the startups in space fields, US in last suppose 10 years, 10 to 20 years, 5,500 startups have come. In UK, it is 3,000. In India, it is 365 startups. China is less than 300. So this is the startup statistics. Next slide, please. Venkat, next slide. Yeah. So we have a lot of job opportunities, space technology in space technology sectors and startups, and very few people are found experts in this field. And as we heard in the previous presentation, more than engineers, technicians, all those play important roles. We don't mean we are. I'm not trying to say that engineers don't have a role, but they are more important. So next slide, please. Taking time. Yeah. So all that, all these technicians part, even Professor Jaideep spoke, we need lot of research fellows. He is talking that engineers, all those scientists, they don't know how to write. Write means attractive writing for social purpose. It should reach to the public. So we need all that. We need satellite technologists, biologists, thinking about our health challenges, manufacturing engineers, mechanical engineers, atmospheric scientists, environmental engineering, all this robotic engineering, electronics, aerospace, ceramic, metallurgical, software, computer hardware, astrophysics, astronomer, all that. So aerospace engineering, all those kind of engineers and technicians are required. There is a vast opportunities in this space sector. And what in generally in India, I can't say about the US. Generally in India, all the engineers that we think that we take up some software jobs, other jobs, and we don't look even in our professors, teachers. There is a lack that they don't guide to go towards aerospace. So that those are the, we can say, like minor challenges. But if now I think after that we start that this courses on that explore the space, and then after these presentations, after the presentation of this Professor Jaideep, I think the students, engineers, whoever are attending will think twice to go to this space. They should think to go to this space. Next slide, please. So, yeah, next slide. So physics, as he has also covered, so I need not talk much. And physics, that plasma, particle, nuclear, medical, all this atomic, molecular, astro, all that physics, the Professor Jaideep spoke in little bit more details. Next slide, please. Next slide. Design engineer, I said, they are important for designing, building, maintaining systems of the spacecraft, launching spacecraft that he has shown in videos also, landing rovers on Mars, building communication satellites, all those. It's so for all the students, it's time for you to look beyond the normal engineering opportunities. We should think, look, search opportunities in space, and space is like a space. So we should think of going to that line. Next slide, please. Yeah. Now, if in India we talk that job opportunities, we can think of National Remote Sensing Center is there in Hyderabad, Satish Dhawan Space Center in there, Bharat BHEL Bangalore, they are working on some space components. Then Vikram Sarabhai Space Center there in Trivandrum, Space Application Center in Ahmedabad, then Satellite Center in Bangalore, DRDO is there in Bangalore and so many other places. So engineers can think of looking for the jobs in this here in this all companies or government organizations. Next slide, please. Next slide. Now job opportunity, if we think in suppose private this thing, Skyroot Aerospace in Hyderabad, Setshore Analytics in Bangalore, Agnikul is in Chennai, Aeton is in Pune, Pixel is in Bangalore, Astrom Technologies in Bangalore, Space Machines in Bangalore, Mahantasu Space is there in Mumbai, and Bellatrix Aerospace in Bangalore. So all those private companies also have entered into this. So we should think of opportunities to go to even private sector. Next slide, please. Next slide. So you can do even pupil after graduation, they need to do that industrial internship. So if you think of going to the space field, you can take up internship and research, and then you can go to Indian Institute of Astrophysics in Bangalore, Indian Institute of Science in Bangalore, Raman Research Institute in Bangalore. Then you can go to astronomy and astrophysics lab for research, National Center for Radio Astronomy. You can go semiconductor laboratories there. Laboratory, you can see that their addresses on that Google. You can go for internship. Next slide, please. Next slide. So with this, I am done. I think I have not taken much time. So it was wonderful presentation, inauguration, and means I thank Venkat to organize such a amazing function, technical function, and there is a good participation from students, even research scholars. So I think next time we will have a further better Zoom conference webinar. Thank you everyone, and thank you. Bye.
Dr. Sharma ji, can
Yeah.
we share your email ID with the participants?
Sure.
Thank you.
Yeah.
We'll be happy to do that. We'll be happy to do
Yeah.
that. Thank you so
Yeah.
much, Dr. LK
Thank you.
Sharma ji, for your
Thank you.
presentation on the career opportunities. Dear participants, I take pleasure in inviting and requesting Madam Manvi Kapoor from IPC, the Global Electronics Industry Association, for a brief presentation. Over to you, Manvi.
Yeah, thank you, Venkatji. Good evening, everyone. So it's my pleasure to introduce myself on behalf of IPC. I am Manvi Kapoor and I lead the Event and Communication Department with IPC India. And let me give you a brief about IPC. We began our journey in 1957 as a not-for-profit trade association headquartered in the US. And during that time, some OEMs felt that a group could be formed to provide assistance to the industry and That is what lead to the information of this association. And we work in 4 regions, North America, of course, US is our headquarters. We have offices in Chicago, and we have offices in Mexico and several offices in Europe. So as of Asia, we are very strong in China, Taiwan, Japan, Korea, and South Asia. In South Asia is in Indiana and Middle East Africa. So we have strong membership in Singapore, Malaysia, Thailand, Vietnam, India, Sri Lanka, and UAE, Saudi Arabia, Israel, and some African countries. So it gives us a great pleasure to be a part of this event with Explore the Space. And as you all know that electronics plays a crucial role in the controlling and monitoring spaceships through various circuits, controllers, and printed circuit boards. And from propulsion system monitoring to flight control and internal and external communication systems, and PCB assemblies play a vital role. And PCB assembly have become essential to the functioning of spacecraft due to their ability to integrate various components and sensors onto a single board. So it simplifies design and assembly process, reduce overall weight and size, and make them ideal for use in space applications. And that's what IPC does to build your electronics better. So as IPC has a space, addendum refers to a set of requirements and guidelines established by IPC for design and manufacturing of printed circuit boards used in space applications. And the addendum is a supplement of the IPC 6012 standard for PCB manufacturing and provides additional requirements for the material processes and performance of PCBs that will be used in the harsh environment of space. So the addendum is an important resource for PCB designers, manufacturers, and assemblers who are involved in the production of PCBs for space applications. By following the guidelines outlined in the IPC space addendum, manufacturers can ensure that their PCB meets the necessary standards for use in space and can help the reduce of risk of failure or malfunction of in critical space missions. Last but not least, last year, IPC developed an international industry networking forum for technology companies, which is called Integrated Electronics Manufacturing Interconnections. So second edition of this IMI event scheduled at Chennai on August 1st and Pune in August 3rd. So these 2-day events bring together industry professionals from the electronic industry, including designers, manufacturers, suppliers, traders, service providers, and technical experts to build new partnerships, gain technical knowledge, and source new products and services. So I would like to invite all companies to attend the IMI show in Chennai and Pune on August 1st and August 3rd, as registration is free and you will have the opportunity to attend the conference and technical session as well as meet industry professionals under one roof. So in order to demonstrate IPC in a very small way, I would like to request Explore the Space to display a very small demonstration of my presentation. Greetings and thank you very much.
Thank you, Madhviji. We have the short presentation on IPC now.
Yeah. So on the behalf of our Executive Director, Mr. Gaurav Majumdar, I am presenting this as he's traveling to South Africa. Can we play the video, please?
Your goal is to build fully functional, highly reliable products in a rapidly changing world. Failure is not an option. To achieve this, you need a trusted source to identify growth opportunities, develop solutions to your technical challenges, and help mitigate supply chain risk. IPC is your source. As a global leader, IPC's mission is to further the competitive excellence and financial success of its members. IPC member companies include OEMs, EMS, PC board fabricators, and suppliers operating in a wide range of sectors, including aerospace, defense, automotive, telecommunications, industrial, and medical. IPC collaborates with industry leaders to develop standards that improve quality, reliability, and supply chain communication. Around the world, IPC standards are associated with nearly every stage of the electronic product development cycle. A skilled workforce is your most important asset as manufacturing continues to advance. IPC delivers cutting-edge education, training, and certification on relevant industry topics online and in the classroom. Individuals gain the critical skills needed to start in the electronics industry and thrive throughout their career. IPC actively engages in government relations and advocates for science-based regulations and public policy, and lobbies for the reforms you need to be successful at what you do best, manufacturing. IPC exists to help the industry create better quality products, enhance skills and knowledge, reduce costs and waste, and influence policies that spur innovation. IPC has become the voice of industry, and as we keep our eye to the future of technology, IPC is the voice of what is next.
So these are the, we have IPC standards, which are the most of the acceptability standards in the electronic industry, and it used by ANSI and NASA as well. In NASA, we have J standards 001. NASA has adopted the J standards 001 for all programs and projects from effective on October 2011. And the dum-dum we are talking about the J standard space ship. It's in the next slide. Can we have a next slide, please? Yes, can I have a next? This so this is our J standard for the space and military applications, electronic hardware dum-dum, to which includes the requirement for soldered electrical and electronic assemblies. Can I have a next slide? So this is the event which we are talking about. Can we have a next slide, please? Is next slide? Yeah, this is the event which we are talking about in August, 1st August in Chennai and 3rd of August in Pune. So basically major focus is on aerospace electronics, and it's in 1st of August. For any information, you can email us on this email ID. It's edindia@ipc.org, or can we have a next slide? So this the email ID is flashing on the screen. Yeah, so you can email us on this ID, gauravmajumdar@ipc.org, and my email ID is manvikapoor@ipc.org. For any information related to the IPC standards or certification and training, so you can just message us for any queries, technical queries. So, and we would like to invite you, I already say that, for this event. So you all are welcome over there and attend the technical sessions, attend the conferences. Thank you. Thank you so very much for giving me this opportunity, Venkatji.
Sure. Thank you, Manviji. Thank you very much. Your presence and presentation added a unique flavor to our program by bringing in an industry association that operates at the global level, IPC, which is the Global Electronics Industry Association. As Manviji mentioned, they have a very big event on 1st August in Chennai and on 3rd August in Pune. We'll be very happy to share the email IDs of Manviji along with the email IDs of the other speakers. Now, ladies and gentlemen, with this, our program comes to a close. I take this opportunity to thank Jaideep and Mr. Sudhirji for his inaugural, and Dr. LK Sharma and Madam Manviji for your presence. Jaideep, can I request a final word from you, please?
Well, I love the other speakers and what they have to talk at the present. Dr. Sharma gave a very good, very good information on the career, especially in India. What is good to see is all the students who are taking part in this program. So I can tell you, I've been working with students for the last 25 years. The people, the students who make a difference are the ones who take part in projects like this, in programs like this. So I can really say that all of you who are taking part will be successful because you have taken the first step in trying to know or get more knowledge about what's going on in the space sector. So congrats to all of you. I can guarantee that every one of you will be very successful in what you do, just because you have the passion to come and do something more.
Thank you, JD, for that. Thank you very much for those encouraging words. Do we have Dr. LK Sharma now? Sharma ji?
Yeah, I'm there. Yeah,
Sharma ji, can we request your last word, please?
so it was means great organization by you, and hopefully, and I trust that all the students, all the participants, delegates, and speakers, they enjoyed their means our company, and next time we will have great success. And although it was a success today also, we were expecting more than 100 plus
Yeah.
participants. So next time we will have big gathering. So all the best to you. Credit goes to you and your
Thank you.
explore the space
It's
and
a
your
teamwork.
team. Yeah,
It's a teamwork, Sharma ji. Thank you so much.
Yeah.
Manu ji, we understand that you are making a trip to Chennai. We'll be happy to facilitate meetings for you. And thank you for
Yeah.
inviting the companies and others for the August 1 and August 3rd event. Can we have a final word from you, please?
Sure. Thank you so very much. I really like the presentation from Joydeep sir and Dr. Sharma. And it was a really great experience with Explore the Space. And I would like to work with you all again. So if any, it's a great webinar actually for the students, faculties, and the dignitaries. Thank you.
Thank you, Manvi ji. With this program comes to a close. As I mentioned in the beginning, we had registrations from 23 different education institutions spread over 15 Indian cities and towns. And we'll be very happy to share the contact details of all the speakers with all the registered delegates. You are free to ask your questions straight to the speakers, and we'll be very glad to facilitate. With this program comes to a close. A very, very good morning and good day for you ahead, Jaideep, and for other friends from USA, and good evening to friends from India. Thank you so much.
So bye-bye, Professor Jaideep. Bye-bye. Now you can have your breakfast.
I will, and my coffee.
Yeah, yeah. And next time I will try to meet you in Florida. Whenever I come there,
Please.
Florida
please.
is Florida. We generally every year I go to Daytona,
Okay.
and Florida is my flight center. So next time we will meet, hopefully.
Please do. I live about 40 miles, 50 miles south of Daytona. So
Very good.
Come
very
during
good.
a launch.
We'll meet.
Absolutely.
See you. All the best. See you. Bye.
We also have a very interesting participant, Mr. Karugaba from Uganda. He has been a great supporter. So welcome to Karugaba. Karugaba has participated in all of the international webinar series that we have been doing. And he is our main connect to the great African continent. Thank you, Karugaba, for being with us here. With these words, this program comes to a close. Thank you all participants. Thank you so much.
Thank you.